November 20, HL paper 1. So this is a little bit different from what we've done in the past, because instead of being usub, it's xsub. Nonetheless, if I just rewrite this like this, we're going to notice fairly quickly I'm going to run into a little problem, because I can replace this with tangent of u squared over 1 plus tangent squared of u cubed. And then I have a dx, but I can't have a dx, because here I'm integrating u's with respect to dx. So I need to somehow replace this with du. So what I can do is I can derive this with respect to u. So dx du is equal to the derivative of tangent of u with respect to u. What's the derivative of tangent of u?
Sec square
Good. Secant squared of what?
of u.
Good. So therefore, dx is going to equal secant squared of u du. Well, this allows us to replace this dx with this. Just right here, we're going to fix the boundaries of integration. So when x equals 0, I'm going to replace this with 0. When x equals 0, tangent of u, what's the value of tangent of u? How do I find u for this? I'm going to take the arctan
It's pi over 4.
of 0.
Oh. But here don't we want 1?
First I'm looking for 0,
Okay.
and then I look for,
Then it's only 0.
it is 0, good. And then 1 is equal to tangent of u. So arctan
Pi over 4.
is equal to u. All right, good. So that's pi over 4. Good. So now I can rewrite this in a more suitable way. So this is tangent squared of u over 1 plus tangent squared of u cubed secant squared of u du. All right. Let's minimize this stuff. Darn. Let's see if we're going to get more space. It's probably going to want more space. Okay. Now, when you're doing these kinds of questions, I find it a good idea, unless you have these in your head, to have your formula booklet with you. Where's your formula booklet? Now, if you're looking at this and your formula booklet, what can you simplify? Right? We've got pi over 2, we've got tangent squared of u, secant squared u, 1 plus tangent squared of u cubed. You should really be in your trig.
Arctan x.
No, you're looking at derivatives. You should really be in your trig functions right here. This is not a calculus thing. You'll notice here, what we're dealing with here are trig equations. So go to your trig equations. There we go. And if you see this one, your Pythagorean identities, 1 plus tangent squared equals secant squared. Well, that means I can rewrite this. This right here will be secant squared, right? Secant squared cubed is secant to the 6th.
Yes.
Okay, so I'm gonna so far so good? Oh, pi over 4. Does that make sense? Right, that's in your Pythagorean identities in your formula booklet. Okay, now this is, we can simplify it some more. What's secant squared? What is secant in general?
1 over cosine.
1 over cosine, good. Tangent squared is sine squared over cosine squared.
Sure.
Okay, so this I could rewrite it this way. This is sine squared of u over cosine to the 4th of u over 1 over cos to the 6th of u du. So far so good?
Mm-hmm.
Okay. Well, then this is going to equal 0 to pi over 4 sine squared of u cosine squared of u du. Yeah? Okay. Now, we're gonna have to find a way to simplify this part. And this is gonna be a little bit more complicated. Okay, you see sine u, cosine u. And we need to simplify this in some way. And we're really not that skilled yet with squares. So we need to simplify this down in some way so there's not a square. But first of all, what can we do with this? What does this remind you of?
Like sine u and cosine is equal to 1.
That's sine squared of u, cosine squared of u.
Yeah.
Okay, but here we don't have that. We've got sine u times cosine u. So if you look at your trig identities,
Sine.
yeah, it looks a lot like sine of 2 theta. But it's 1/2 of that, right? So this will be 1/2 of sine of 2u squared du. I'm going to start pulling out, let me fix this u right there so it doesn't look like a 4. I'm going to pull out, so 1/2 squared is 1/4. So I'm going to pull that out. Now we're left with sine squared of 2u. Now I've got a couple possibilities here. You were telling me sine squared of 2u plus cosine squared of 2u is equal to 1, for example. And that's something we could think about. Here's a different one, and this is not an identity that the IB gives you or asks you to know. It's called the half-diagonal identity, and we're going to try and derive it right here. And if you start with this, well, let me start with the cosine of 2 theta in general. What's the cosine of 2x equal to?
Cosine of 2x.
Mm-hmm. There's multiple possibilities,
Yeah.
right? One of them will be 1 minus 2 sine squared of theta. Oh, sorry, that's x right there. Okay. And the reason I'm doing this is I'm going to try and get sine squared of whatever right here. So this is 2 sine squared of x equals 1 minus cosine 2x. Therefore, sine squared of x equals 1 minus cosine of 2x over 2. So far, so good? I'm now going to let x equal to 2u. This will give you sine squared of 2u is now equal to 1 minus cosine of 2 times 2u over 2. And at this point, I no longer have a squared, and I've got values that we know how to integrate. And this is not easy. I'm not saying it's easy at all, but this is...
What was the name of this method you used?
Well, really here, this you already have, right? This is starting from cosine 2x.
Yeah.
So you already have that. This, in the end, will be called like a half-angle identity, but it's not part of the IB scheme that it gives you. But they have used this trick in others, so it's not a bad one to be able to derive. You don't have to know it by heart, because really, why bother? But if you can kind of remember that when you're looking for a sine squared of something, this is a worthy consideration if you're trying to simplify it down. Okay, so now this will allow us to go from 1 over 4, pi over 2, 1/2, 1 minus cosine of 4u du, which will equal 1 over 8, 0 to pi over 4, 1 minus cosine 4u du. And now I can just solve this. Okay, what's the integral of 1 with respect to u?
U.
Yeah, it's just u. And cosine 4u integrates to what?
Can we say that it was sine and 1 over 4 sine 4u.
Good. It's equal to the sine of 4u over 4, or 1 over 4 sine 4u. And this is from 0 to pi over 4. And at this point, I can just plug in my values. And I'll have found it. Because originally, that's what we were being asked to ask. We were asked to find, is to find the value of this. Now that we have this will finally equal 1 over 8. So u at pi over 4 is pi over 4. Sine of 4 times pi over 4, what's the sine of pi?
Sine of pi is
In
1
the
by
unit
0.
circle. Good. U at 0 is just 0. What's the sine of 0?
Is 0.
Good. Therefore, this is equal to 1 over 8 times pi over 4. It's pi over 32 is our final answer. This is not an easy problem. All right, for the 8 points that it is, I think this part right here is something you can quite comfortably do reasonably well. It requires minimal manipulation, recognition of trig equations. Starting right here, this bit right here, is going to require some intuition. And this is where the HL is going to kind of separate the candidates. Look at this. It's 8 points, but it's also question 9. So it's meant to be more difficult. The questions in the IB exams get progressively more difficult. So the ability to do this is going to separate kids who are going to get 4 5s from kids who are going to get 5 6s. So if you want a 5, a 6, or a 7, if you want a 6 or a 7, this is the kind of practice with trig equations that we haven't seen in a while now that we're working on calculus. So this is a good problem. But that's what you want to spend a little time focusing on. I would recommend practicing this one on your own, erasing all this, and trying it a couple times until you're comfortable. You might even think about making a little video